Today, let's look at sections 4.1 and 4.2 put together because they're both involving graphing quadratic functions. So let's review what a quadratic function is. Remember that a quadratic function is an equation in which the power of x is 2. Okay, remember we do not want to have any products of variables and no variables in our denominator. All right, let's review the parent function. So the parent function of our parabola is simply y equals x squared. And the parent graph, remember, is a parabola. Okay, so remember when we classify a function, we call it a quadratic function. When we talk about the graph, it's a parabola, which is that U shape. Recall the parent function starts at the origin. Our vertex is at the origin, and we go up 1 over 1 for the second 2 points, and then up 4 and over 2 for our other points, okay? This is not a linear equation, so there is not a slope. It is a parabola, which is a curve. Okay, what are our solutions of a quadratic equation? That's what we really want to focus on in this unit, is determining not just the graph, but the solutions. So the solutions of a quadratic equation are the x values that make the equation equal 0. Hence, we plug in 0 for y, or f of x, and then solve for x. We can solve quadratic equations in numerous ways. And our first way is going to be solving by graphing. We will then look at solving by factoring, the quadratic formula, completing the square, and so forth. But today we'll focus on solving by graphing. So what we're looking for is when that y value is 0. Solutions are therefore known as intercepts, particularly x-intercepts, because again, we're looking at where it crosses the y-axis because we want our y value to be 0. Sorry, the x-axis because we want our y value to be 0. They're also called zeros because again, we focus on when it equals 0. And lastly, we can also call them roots. So you will be asked to either find the roots, find the zeros, find the solutions, find the intercepts. That all means the same thing. All right, let's talk more about the graph of a quadratic, aka let's talk more about parabolas. We know that they have a U shape, and we've memorized those key points for our parent function. But let's talk more properties about a parabola. A parabola has an axis of symmetry. And what the axis of symmetry is, and I will draw that in, is an imaginary line that goes right through the vertex and creates 2 symmetric pieces. So notice in my parent graph, it went right through the origin, and then I have 2 symmetric pieces on the left and the right. So that orange line is our axis of symmetry, otherwise known as the AOS. Now, it's very important for you to memorize the formula for axis of symmetry. The formula for axis of symmetry is x equals negative b over 2a. Notice that x equals is really important because axis of symmetry is a line and it's a vertical line. So therefore, all vertical lines are in the form of x equals. So please, when I ask you what is the axis of symmetry, don't just say something like 2. Tell me x equals 2. Okay? Now that we have the axis of symmetry, let's talk more about our vertex. Remember, the vertex now is the point at which the axis of symmetry passes through. And again, I'll use AOS for axis of symmetry. Recall it is either the highest or lowest point of our parabola. And to find the vertex, you're going to find your axis of symmetry. That'll give you your x value. And we plug that x value into the equation to find our y value. X value. Okay, so again, we will find our axis of symmetry. We'll take that x value that we find. We will plug it into our equation to find y. That y value then gives us an x and y, which is a coordinate, and that coordinate is our vertex. Remember, we can also use our transformations to find the vertex. Okay. Now let's move on to describe that vertex more. We said that it's either the highest or lowest point. So when it is the highest point, we call that a maximum. So our max is the highest point, and we have a maximum when that graph is going to go down, right? A maximum means that the graph is going down and we have a highest point, which means, how do I determine if it's going down? We have a flip. So we're going to look at that a value to see if it's negative. Just going to use a different color to separate. This. Okay. So when vertex is the highest point, and in the equation, a is negative because that means we flipped. Our minimum is when we have a vertex that is the lowest point, and therefore the graph opens up, so a is positive. There was no reflection. Now let's talk about the equation themselves and how it could be written. So with a quadratic equation, we'll see two ways. General or standard form is what the first one is called, and that's f of x, or remember, y equals ax squared plus bx plus c. So a, b, and c are coefficients and constants. We have our variable of x, and notice the highest power is 2. So this is our general form. We focused on vertex form. So vertex form is when we can pick out those shifts very easily. This is a times x minus h all squared plus k. Remember, when it's in vertex form, we can see those transformations and we can say, oh yeah, we're moving to the right h units, or moving up k units. And this tells me what that vertex is. So that's why vertex form is so great, because right away you can determine that that vertex would be h comma k. I moved to the right or to the left, h units, and I went up or down k units, and that tells me my vertex. Remember, a tells me whether I have a stretch or a shrink, and if it's negative, I know that I have a reflection as well. Okay? Alrighty, so now that we have some vocabulary, let's go through some examples. Our first example, I'm going to actually have you go back and do on your own. This is in vertex form, which you are very familiar with. for graphing, right? We're going to check out our transformations, find our vertex, find our axis of symmetry, and then I'm going to ask you to continue to find the rest of the information here. Because it's in vertex form, you do not need to use this chart. Okay, so after we go through the examples, you go back to number 1 to finish that. Number 2, however, is in standard or general form. So by looking at this, I can't just determine, oh, I'm going to the left this many units and up, so here's my vertex. So what we need to do instead is we need to identify A, B, and C. So I am in standard form, so A is -2, B is the coefficient in front of X, and C is my constant, which is -5. I'm going to start by finding that axis of symmetry. Remember, the axis of symmetry is the equation x equals -b over 2a. So when I plug that in, I get -4 over 2 times -2, and that gives me that x equals 1. So my axis of symmetry, remember, I'm not just going to say 1, it's an equation. So I'm going to say that x equals 1. Now, to find my vertex, as I mentioned up above, we take that x value from my axis of symmetry and plug it into the equation to find y. So my vertex to find y is going to be -2 times 1 squared plus 4 times 1 minus 5. Please be very careful with your order of operations. We're squaring 1 and then multiplying by -2. So this would become -2 plus 4 minus 5. -2 plus 4 is 2, and 2 minus 5 gives me -3. So our vertex is a point. We plugged in 1 for x, and we got a y value of -3. So my vertex is 1, -3. Now it's asking me to find a y-intercept. How do I find a y-intercept? Let's recall here. To find a y-intercept, plug in 0 for x. Remember, we just had a test on that in chapter 2 for linears. And the same thing happens. To find y-intercepts, we plug in 0 for x. So let's do that. We would have y equals -2 times 0 squared plus 4 times 0 minus 5. This would give me 0 plus 0 minus 5, which is -5. So my y-intercept is 0, -5. All right, now I'm going to go about graphing. So to graph this, you have 2 options. You can make your table of values, or knowing your vertex and transformations, you can just plot. So I'll do both. I know my vertex is at 1, -3. Now, in a parent graph, it usually goes up 1 over 1. But notice I have a -2 out front. So that means that I'm going to flip, I'm going to go down, and that stretches by 2. So instead of going up 1 over 1, I'm now going to go down, but instead of going down 1, I'm going to go down 2 over 1. Down 2 over 1. And look at that, we hit that y-intercept of 0, -5. And remember, my other point then is normally to go down 4, but we're going to go down 8 units. And 8 units just knocks us off the graph a little bit. So there we have it. I'll now connect that curve. Remember, this is a U shape, so make sure it is curved. If you feel comfortable with that, then again, you do not need the table. If you are not comfortable still with those transformations, then the table is there for you to figure out additional points. So I always put the vertex right in the middle, and then because we're symmetric, I find a point on each side. So for example, if I use 1, I'm now going to test 2 and 3. And because 2 is 1 unit away, I know 0 is also 1 unit away. They will have the same answers. And if I plug in 3, that should give me the same answer as when I plug in -1. So then you would just plug those in and calculate. We know when we plugged in 0, we got -5, which means when I plug in 2, I'll also get -5. If I plug in -1, we can do that. -1 squared is 1. 1 times -2 is -2. Plus 4 times -1 is -4. And then minus 5, that gives me -11. And notice where we had already plotted, right? This went up to 10 and now 11. So we are in good shape there that our points we plotted were correct. So it's your choice if you want to use the table, but you do not have to use the table. Okay? I'm just going to make a note right there. All right, so now by looking at this parabola, we want to determine the roots. Okay, so remember, if we go back to our notes up above, the roots or the solutions are where the x value makes the equation 0, aka where y is 0, or it's the x-intercepts. So if we look at our graph, here is where y is 0, right? I'll just dot this and then erase it. All along here is where y is 0. Do we see our graph hitting that orange line? No. So since it never crosses that x-axis, it's never going to have a y value of 0. That means that we have no real solution. Notice I'm writing real, and that's because we are soon going to talk about imaginary numbers. Okay? Now, if we look at this parabola, does it have a max or a min? It has a highest point, so it has a max. And now let's review domain. Domain are all of the x values. So if we look to the left, we look to the right, eventually, since this curves, every x and every y will be used. So we can write that as -infinity to +infinity, or all real numbers. Our range is our y values. We always start with the lowest. Well, what's the lowest? It's going down forever, so it's going to start with -infinity, and then we look, does it go up forever? No, it stops at -3, but it's included, so we use a bracket. Okay, so there's all the information that you're going to be asked to find. I'm going to let you try example 3 on your own, but I am going to make one little note for this problem. For this problem, your roots are not exact values. So what I'm asking you to do is to estimate the roots. Okay, so that's my hint to you for that one, is estimate the roots for this problem. We will talk about notation a little bit more tomorrow once we go over this. Everything else you should be able to find and graph and plot. Okay, so use example 2 to help you solve 1 and 3. Again, remember, roots are where we cross that x-axis. Once you have finished those graphs, I'd like you to fill in the blanks based upon the vocabulary from the first page. All right, let's look at equation writing before we end our notes. So, to write a quadratic equation, okay, we have a couple of things we can do. We can write it in vertex form, or we can write it in standard form. When I'm given a graph, it's very easy to jump to write it in vertex form. So let's do that for our first problem. So given this graph, let's first write it in vertex form. Let's note here what we have going on. Our vertex itself is 4, 1. And notice we have a stretch, right? Because my next points from my vertex are going up 2 over 1. So we have a vertical stretch of 2. It's opening up, so it's positive. So therefore, that function is y equals 2 times x minus 4 all squared plus 1. right? Again, we went to the right 4 and up 1 to find that vertex. So if I look at all my transformations, we have our stretch, right 4, up 1. And don't forget about the quadratic. So that is vertex form. Now it's asking me to write it in general form or standard form. So from there, I'm just going to rearrange this to general or standard form. I'm not going to start from scratch. So first thing I'll do is I'll FOIL. I'll have 2 times x squared minus 8x plus 16. Distribute the 2x squared minus 16x plus 32 plus 1. So this gives me an equation of y equals 2x squared minus 16x plus 33. Remember, instead of y's, we could always use f of x's as well. So this is our general or standard form. Okay, so when you're given a graph, I would certainly start with vertex form and then rearrange to standard form. Same deal, if I had just said write it in standard form, don't get nervous. Start with vertex form and then rearrange. All right, and our last problem is when we don't have a graph. And specifically, we don't have the vertex. All I have are points that it passes through. Well, to do this one, we want to start with general form. And remember, for general form, it is that y equals ax squared plus bx plus c. So what we need to find is a, b, and c. So if I'm looking for 3 variables, we need to come up with 3 equations. So we're going to start this together, and then I'm going to let you solve this system on your own. So our first equation is going to come from our first point. This is a x and a y. So I'm going to plug that in. If I have 1 being my y, I'll have 1 equals, we don't know a still. My x value of this coordinate is 1. I don't know b still, and my x value again we said is 1, and we don't know c. Now I'm going to use the second equation. So we have a 2 and a 4. 4 is my y value, so that will be, again, plugging in 4 for y. 4 equals, we don't know a. Our x this time is 2. We don't know b, but our x is 2 still, and we don't know c. Now I'll use my third point. Plug in for y, it's 9. We don't know a. Plug in for x, it's 3. And now we have 3 equations. Well, let's clean these up. So just for your notes wise, I'm just going to jot down that that's where we used these ordered pairs to come up with these equations. So now I'm going to simplify that. So all of those lead to the equation for the first one is y equals a plus b plus c. Very nice there. Our second one leads to 4 equals 4a plus 2b plus c. And our third equation leads to 9 equals 9a plus 3b plus c. What I'm going to ask you to do is now solve this system, just like we did in our last chapter, for A, B, and C. And once you have A, B, and C, you're going to plug those in to that general formula. So whatever A is goes into my first slot, whatever B is goes into the second slot, and then whatever C is goes into the last slot. Once you have those numbers, you can clean it up and give us your final answer. And we'll check that tomorrow. Have a good one.